Hello, this is Jessica Braithwaite. My topic was addressing fraction, addition, and subtraction errors. I chose this topic because I honestly did not truly understand fractions until I took Dr. Strawhecker's math class while I was getting my Bachelor of Arts degree in teaching as a 22-year-old. I found it utterly fascinating that fractions actually had meaning and could be understood and worked through and not just simply looked at with procedural matters such as invert and multiply, take the denominator times the whole number and add the numerator, etc. I honestly got good grades when I was younger and doing fractions, but I had absolutely no conceptual basis for them. And when it came to story problems that dealt with fractions, I rarely would get them right because I didn't understand what they were asking. I don't want other kids to feel that way and have absolutely no foundational conceptual understanding of fractions. It boggles my mind that I was never taught that, and I don't want other kids to feel that way someday. So throughout my presentation, I have just funny little memes of how teachers and parents and people in general just look at fractions. 5/3 of the class don't understand a word I'm saying about fractions. I believe this is so true. Teachers have a hard time explaining fractions to kids besides just the procedural part of it. And so the cycle is sadly never broken. So I'm hoping to end the cycle of people having struggles with fractions. The professional article that I read, it followed the author doing a study with some kids, and she introduced the kids to fractions with these 4 bullet points that I found were the most important. Number 1, she had a purpose and intention for beginning her lessons. I think that a lot of teachers fail to do that, and it's an absolute essential to any lesson that is planned. You have to have a purpose and intention of what you want the students to learn and how you want to teach them. For example, she wanted the students to consider not only the number of pieces in a whole, but also the fractional size of the pieces involved in the problem. For example, 3/4 can be thought of as 3/1/4. And she wanted to know if the students knew how big those individual pieces were versus, say, an eighth. She also introduced the students to the fraction problems beginning with story problems. I thought that was amazing. Usually when fractions are first taught, it's just a number sentence. 1/4 plus 2/4 equals what? She started right out of the gate with story problems. I'm used to seeing a whole bunch of number sentences on the paper. The kids have to add like denominators, and then maybe there's 1 or 2 story problems at the end for higher level thinking. I speak from experience with this because my son just finished 4th grade, and that's exactly what his textbook was and how he was introduced to adding like denominators. She began with story problems and cognitive high-level thinking right out of the gate so that they could build a conceptual basis for learning. In the article, the students led the conversations and thinking. She prompted them with such things as, tell me more, and what if this would happen, but the students were the ones that were explaining why they were doing what they were doing and why it made sense to them. I loved how she actually, even in some of the conversations she had, she introduced the misconceptions of adding the denominators, as in, what if you had 3/8 plus 1/8? Why wouldn't that be 4/16? And the students had to describe that misconception for her. Also, I believe the biggest thing about the article that I learned is that the students led the progression of what type of fraction problem was to come next. And in the next slide, I'll explain that a little bit more. But the typical progression of students is right here. this is what textbooks usually introduce fractions with, and this is how I remember learning it. The adding and subtracting like denominators, and they add and subtract unlike denominators. And the article, she had the students lead the thinking, and whatever their thinking was, it led to the next step and their thinking sequence. As you notice, the students in the progression of the article here, they didn't add and subtract unlike denominators till the sixth step. In a textbook and how I remember learning it, it was the second step. And as Mac noted in the article, the student wasn't ready to process this yet. They wanted to subtract from a whole number first, and then subtracting from a mixed number first before they even dealt with unlike denominators. So I found that extremely interesting. And here the student, again, they were ready to subtract from a mixed number, and then clear down here, a textbook usually introduces that as the seventh step. This also is a picture of how students solve the problem in the article. Again, here is one of the story problems that she introduced to them, and here is their thinking. You can see that their thinking here was a whole minus 5 6 equals what? And they knew that we were working with sixths, and so they put wholes in sixths. So they had 6 6 and then 12 6 and then 18 6, and they took that and subtracted it. It was awesome in the article that they saw that they needed to rename the fraction. They renamed it and found a whole number, or I'm sorry, a mixed number all on their own. Without ever being taught what to do or the procedure to do, they figured this out all by themselves, simply because they had a good conceptual foundation of fractions. On my next slide here, we talk about how the article was connected to the textbook. I found that the article and the textbook both found common misconceptions of adding and subtracting fractions. The first one, of course, both the numerators and denominators, you add both of them. That was a common misconception that both of them found. However, the difference is the article treated how to help that misconception different than what the textbook said. The textbook already predicted that that might be a misconception. The article, the Mac approached it in such a way that the kids didn't even have that misconception in the first place, because they had such a good basic foundation of fractions that they never even thought that that would be a problem. In fact, she presented it to them as a misconception, and they right away negated that that could be an answer because they knew what kind of parts they were working with. So I found that interesting. Another thing that I found that they said was the same was that finding the common multiples of a problem with unlike denominators, that was an error or misconception in both the article and the text. However, here in the text, they give a more procedural way to help with it, whereas in the article, she gave a more hands-on manipulative way with visuals that the kids would take different parts and visually compare them instead of listing the multiples and factors for that matter. Estimating as well was an error, but again, when students don't have a strong conceptual basis of fractions, then they're not going to be able to estimate, therefore not going to see if their answer is actually a good one. And then connecting Nancy Mack's study to dimensions of a productive classroom. So I picked two things that a productive classroom should have. I just picked on 2 bullet points because the article really only focused on these 2 things. So the mathematics part of it includes developing procedural proficiency in conjunction with conceptual understanding. Mac in the article did this 100%. Her conceptual understanding and the kids being able to understand the fractions was out of this world. I honestly felt jealous that the kids knew so much about fractions and could manipulate them to find equivalent ones and realize where wholes were and what parts they were of the whole. And then developing the productive habits of the mind. These kids are going to grow from what they knew about fractions, and you could tell that their thinking just evolved as each step was done in their thinking sequence. And then the cognitive demand, like I said earlier, this was they struggled through some of the problems, but in the end, then they could have ownership of the rule or the procedure that came from that struggle. So they were learning so much from that. And like I said before, when kids are just given a number sentence like 1/4 plus 2/4 equals what, there's no struggle in that. They had to struggle through a high cognitive demand story problem, and then they could have that ownership of what the procedure is and understand it. Finally, in wrapping it up, I took a quote from the article, and it says to listen carefully to your students to determine whether the sequence in which they encounter problems involving addition and subtraction of fractions aids them in making connections and developing computational fluency. I thought that was awesome. You need to make sure, like I have expressed in this class already, that you're listening to the students, not just going through the textbook and doing what the textbook thinks that you should do and in the sequence in which the textbook presents it. Listen to them and make sure that their thinking is in line with what is to come next. And if you need to skip around and do whole numbers first before you do unlike denominators, then do so. I am definitely going to use this information with my own children that are going through those middle elementary school grades right now to help them build an understanding, so then the adding and subtracting fractions make sense, and they can dive into it and tell me why they're doing it and explain the parts of the whole instead of just doing procedural drill and kill. Then later on, if I do end up teaching again, I want to break the cycle of students not understanding fractions and just doing it as something that they hope they remember the right procedure to do. I'm so excited that I myself am continuing to learn more about fractions so that I will be a better teacher someday to be able to have other children love fractions instead of shy away from them.